Assalamu alaikum warahmatullahi wabarakatuh. This is Ali Darwish, and today I'll be talking about the full wave rectifier, which uses four diodes. The full wave rectifier converts the alternating current to direct current. So we all know that the alternating current wave, it's a sinusoidal that have two sides. Let's assume that this is the positive and this is the negative side. Let me start explaining to you the positive half cycle. So let me assume here at the graph, this is the positive. For now, this is the positive and this is the negative. So when the conventional current moves from the source to the positive side, it will reach up to point B. At point B, we have two choices, or the current have two choices, either to go to diode number 4 or to go to diode number 1. We clearly see diode number 4 is connected in reverse bias, so we cannot go through diode number 4. So we have to go to diode number 1, and we see clearly at point C, we cannot also go through diode number 3 since connected in reverse bias. So we will go through the load, then back again to point A, or back to point A, we will reach point A. So here at point A, we have the voltage or current have two choices, to go through diode number 4 or to go to diode number 2. Both are connected in forward bias, but we know that the voltage always go from high potential to low potential. At point B here we have a high potential, but at point D we have a low potential. So clearly we cannot go from A to B since B have a higher potential than A. So we'll go through diode number 2 to point D and then again back to the source, and this explains the positive side of the half cycle, which actually when we graph the DC wave, it will be this side. Now let me move to the negative half cycle. Now let me change the assumption, so this will be negative and then this will be positive. So when the current moves from the source, it will reach to point D. Then we cannot go to D, diode number 2, since it's connected in reverse bias. So it will go to diode number 2. Then from C we cannot go to diode number 1, and since also connected in reverse bias, so it will go to the load and then it will reach up to point A. At point A, as we have mentioned previously, we had point B that was the high potential, but at the negative side, point D will have the high potential for the negative side, okay? So from point A, we cannot go from low potential to high potential. So D have a higher potential than point A. So the current cannot move through this side, so it have to move through diode number 4 to point B. And also we have mentioned, as point B we have mentioned, or the same story will happen at point B. We cannot go from high potential to low potential, so we cannot move to point C. So from point B we'll go back again to the source. When we graph the wave that will be happened or will be out from the rectifier, it will be like this. But we know that our phones, laptops, anything that need the DC needed to be stabilized to as much as possible. So here we used a capacitor. It's a filter, so it will make the wave smoother. It will be, I brought it here in and the blue color, it will be smoother with the capacitor. We can also improve it by putting some kind of elements, but this is the basics or the theorem behind the full wave rectifier, and this is all what I want to explain to you. Thank you for listening.